Oh, we're live? Oh, man. Cutting into my fun time exploration playtime. Well, welcome to the Aquarium Academy. We are going to talk about ocean exploration today. I have Jen helping out behind the booth with all this fun stuff, making fun things invisible sometimes. Luke is on question control, so you can text us so many fun questions for Luke. Let's see if we can test his speed writing skills. Right here, this number, 56295 or 562-286-1838. That's a different number. You shouldn't call that one. This one we can only receive text to. If you try to call, we don't have the ability to answer those calls, but you can text us right this number right here. And if you still want more answers, or if you have really big questions, we have an email you can talk to us at too, live@lbaop.org. Or if you're not watching live Friday at 10 o'clock, you can email us questions also. Our educators will be monitoring the email, and we can get back to you about your very fun science questions. Well, science exploration is the topic for today, so we should probably discuss what it takes to explore. How do we explore? Let's just imagine our immediate space. How do you explore that space? It could be kitchen, living room, maybe you're watching on the back patio. How do you explore around you? What are we using? Our basic senses. Now, we have 5 basic senses, but scientists are saying that we have up to about 20 different kinds, like balance is one of our senses. Knowing where our arms are in relation to our body is a sense, but our 5 basic ones are really how we do a lot of the exploration. Our eyes, ears, our sense of taste. Don't taste the science today. Our sense of touch. Which one did I miss? Smell. That's it. So today you might get to smell some science, but underwater, that's tough. We're not going to taste the science today because it's going to taste bad, but we are going to use our eyes and ears quite a bit. So when you explore the space around you, you might recognize sounds or sights, or even just the texture. Maybe it's a cool tile floor, you know that's your kitchen. Or maybe it's a really warm wall that's by the stove or oven. So we explore with our basic senses. Well, how do scientists explore the ocean? Are they just out there wandering in the water doing this? Maybe a long time ago. Really, ocean exploration has a huge history. It's been going for as long as people have been near the water. Back to the Pacific Islanders moving across the Pacific Ocean, people from mainland Asia moving off to the islands of like Japan and Taiwan and Indonesian islands, and even the ancient Vikings potentially reaching North America hundreds of years before the rest of the Europeans did. So ocean exploration has a huge history. We're not going to cover all of that. We're going to cover like this much of it. We're going to cover what we do now for modern exploration. So how do we explore the oceans now? Typically, we might think of something like a submarine. We've created technology that allows us to do what the sharks do every day, or what the fish do every day. But do we only explore the ocean with submarines? Or are there lots of other tools at our disposal? How else would we explore the ocean besides just a submarine? Now remember, when we say the ocean, it's the whole thing. From shoreline to shoreline, sea level to sea floor. How do we explore that space? You might have done this already this summer. Did you ever go to the beach? Look for a special kind of rock or shell? You explored part of the ocean. Tide pooling is a method of exploration. In fact, we do what are called bioblitzes. People will go out and record things that they see while they walk along a section of the beach because we need to know more about that specific zone of the ocean. There's researchers that only look at what the animals that in the intertidal zone from high tide to low tide are doing during a tidal change. But then there's other scientists that are exploring the deep, deep sea with special devices like submarines or remote operated vehicles, ROVs, or even autonomous vehicles that you program it, put it in the water, and it does its thing, comes back to you, and they'll download all the data. So ocean exploration is pretty widespread in terms of what we can do. Let's take a look at some of the things that we do in our modern era to explore the ocean. Jen's going to show us something that we can look at, or what scientists are doing while they explore. And let's talk about what we see up here. Now, Jen's picking off the top of her head. We talked about what to look at, but Jen also got to go hang out on a research vessel called EB Nautilus. So Jen really knows some cool things. She might have to correct me in a couple things I say wrong, but that's okay. So while we learn about ocean exploration, make sure that if you have questions, you can ask us. Or if you're curious about learning more about a particular topic we bring up, let us know. Now this is the boat. Ship is probably more apt of a term for the thing that Jen was on. This is the Nautilus. Now we've partnered with some of their people before. They will bring on different educators and scientists to do this, talk directly to the public, the people that are on watching their videos. They also have people up in this room back here that are driving the ROV, that are talking to their public. They will live stream what they're doing. And that's kind of the cool thing, is their ROVs are back here by these big crane arms. And they'll send them into the water. And during the dive, it takes, sometimes 2 to 4 hours to get down to the space you need to be in. Rather than just like putting elevator music on for that, they talk to the public while they're there. So that's a great time for you to kind of get amped up, see what you can talk to the scientists about. But then once they do find something, everything becomes amazing. And they've had some pretty cool discoveries. They had a visit by a sperm whale one time. They found what's called a whale fall, which is when a whale has passed away and it sank to the bottom of the ocean. They didn't know it was there. They were actually looking for, I think, methane gas seeps or something else in the area. And they drove past, they're like, oh, don't worry, we'll come back, we'll come back. And then the scientists were like, come on! Because it's so rare to find these things, they actually turned around and came back to the whale fall. Whale falls are really an ecology that we've only started studying in maybe the last 10 or 15 years, and they're not common to find, so it's very exciting when you do get to find one. Now, some other cool things that this ship can do is that on the bottom it has special technology to map the sea floor. So if we could just like pick it up and look at it, you could. The magic of the internet. We can disappear at will. So the research vessels, they have special bottoms to the boat that allow them to use sonar to map the seafloor. Well, how much do we actually know about the seafloor? Have you ever heard that, like, we only have explored 5% of the oceans? That's a number that's kind of calculated based off of a lot of different variables. But in general, we've mapped quite a bit. And this is what some of that sonar mapping looks like. So the colors are different elevations. So here, I think these are in meters, right, Jen? These should be meters. So at 3,300 meters, that's about, what, 11,000 feet maybe? So this is about 10 to 11,000 feet down, this abyssal plain. And then you can have like craters or mountains or even a whole bunch of other things. And the closer to the red coloring you get, the closer to the surface you are. So they need to map some of these because we don't know where everything is. If you've ever seen one of those big global seafloor maps, that's an estimation based off of a lot of other variables. They didn't perfectly map or photograph the seafloor. That's a mathematical calculation based off of other observations. This is what an actual seafloor picture is. They've actually mapped this with the ship. And most of the coastal zones within the first, 50 to maybe 150 miles offshore have been very well mapped. But a lot of those empty spaces in between where we're not shipping things across the ocean, where there's not a lot of people that go in that area, those are much less mapped. But even then, some of the original maps need updating. You know how they originally made maps back in the day? It actually was a very special job. Somebody on a ship would be drawing what they see on the coastline as they go around. And they had to be pretty accurate about their coastline. Now, if you needed to know how deep something was, there were no cameras back then. This was your technology. And you would measure 1, 2, 3. Great workout for your arms if you're the person that has to, count how many leagues under the ocean that thing is. But they would drop a weight down. They'd steady the ship, drop a weight down, and count how many fathoms it gets down to. So a fathom is about 6 feet, was around the average wingspan of a sailor back in the day. So that's where you get, like, a fathom is 6 feet. It was about a wingspan of a person, okay? And they had markings. So you could also measure out on the rope. And so you could be like 1 mark, 2 mark, 3 marks. in case you had a very short fathom reacher person. I don't know. But it's like a foot was based off of an actual person's foot. Measurements back in the day needed to be a little more precise, like they are now. And so they've been trying to unify that a lot. Nautical measurements are a little bit different than measurements on land. Like a nautical mile is like 1.1625 miles. If you know your calculations, you can estimate what those are supposed to resemble. So there's still some of that ancient naval history involved in our exploration and how far down things are. Most of the time now we're using meters for depth, or meters or miles for length across the surface. So there's been updates, but it's very, very different than it used to be, and lots of really interesting technology. So that's just how you map the floor. But what if you need to get something from down there? You find a methane gas vent, or a hydrothermal vent, or even a fun little animal that you need to make sure is a unique animal. Pictures alone may not help. So in a lot of cases, scientists will have to take samples of things. Samples of the gases coming off the vents, samples of the soil, samples of an animal. They do sometimes collect animals so they can genetically test who it is, how closely related is it to something else. Now this is Hercules. Oh, this is Sebastian. This is on the Falcor. So not like Sebastian. They like puns too, just like I do. And Sebastian is a lot bigger than you think it is. This remote operated vehicle is probably 6 to 8 feet tall, and I think they weigh almost 4,000 or 5,000 pounds. They're like a small vehicle that they would drop in the ocean. No space for people, and that's important. If you think about how deep a submarine with people in it can go, it really depends on the kind. Military subs are, I think, at most 600 to 1,000 feet down in the water. That's not very far, considering the deepest part of the ocean is 37,000 feet, but for the military, they don't need to operate that deeply, so they don't have submarines that go that deep. But researchers do want to go that deep. One of the famous subs, at least from when I was a kid, is Alvin. So Alvin was a very deep diving sub that could staff, I think, 2 or 3 people, and could withstand the pressure of that depth. So that's one of the challenges. So if you're in one of these things, this is actually a sphere that they're in, and then they actually put the rest of the construction materials, all the rest of the sub is around this sphere. So some of the ancient diving technology is using a bathysphere. You're literally in a giant metal ball with a window that you can look out. And that sphere is, because of the pressure, the best shape to sit yourself into, because that can equally distribute all the pressure around it. So for building bridges, triangles are the best shape. For building submarines, spheres are the best shape. And so these two people might be in the submarine for hours and hours and hours. And they can only get to a certain depth because every submarine has a crush depth. How far down can it actually go before damage happens? You don't really need to go that far down, usually, to find something cool. Like we said, you can find stuff on the shoreline. But if you need to go down to the extreme depths, you can use submarines with people in them like this, or you can use ROVs. Now, ROVs are still attached to the vessel. So there's big power cables that attach to the vessel, and the crane arm will drop this, not like, they like lower it into the water. And it has a limited length of space it can venture away from the research vessel. But the research vessel also has to drive or steady itself as the submarine moves. So if the captain of the vessel is saying, we're going to move this direction at 5 knots, not quite the same miles per hour, but 5 nautical miles per hour, the submarine has to go the same approximate speed, because otherwise, it's like if you're trying to walk your dog, but your dog walks you instead. You don't want to drag the research vessel underwater, so you have to match speeds and direction. So if the vessel has to turn 12 degrees to one side, the submarine has to have either enough slack to allow that to be different from them, or they have to follow perfectly. So there's communication between the drive team of the ROV to the ship captain. 2 completely different teams driving 2 completely different vessels attached to each other. There's got to be a lot of communication and a lot of work to help explore the oceans. Now, this is another side view of Sebastian. These are the sample tubes, I believe, up here, where they can collect different things. So sometimes you take a core sample, and literally it's just an empty tube that you shove into the soil or the dirt or whatever is on the bottom there, and you have to gently pull it up. Because if you pull it up and, there's a nice wave that comes by and you jostle it, all that sand falls out. That's actually what happens pretty regularly. So the people controlling the crane arms, not the person driving the ROV, has to communicate with the ROV driver so the ROV doesn't go anywhere while they're picking up their samples. Imagine if you took your entire family to drive your car to the grocery store. One person's got the gas, one person's got the brake, one person steers the car, one person uses the blinkers. There's going to be a lot of communication because there's a lot of people that have a very different job. Now, some questions have popped in from Miss Williams' class. How do explorers stay safe while exploring the ocean? That's a big concern. So this is why there's remote operated vehicles, because you might get injured. There might be things that happen to these submarines while they're down at the bottom of the ocean, which actually almost happened to James Cameron. So if you get to watch the documentary that was produced by James Cameron's submarine Challenger Deep, there are some pretty scary, dangerous things that happen in the process of doing the test dives. So you do as much as you can. There's lots of safety checks. There's lots of oversight. There's lots of test runs. You basically talk to your entire team that's in this control room to make sure that everybody knows exactly what they're supposed to be doing, because things can happen. The ocean is not flat like a lake or a pond. There's some rocketing going on. So there are some hazards to look at, but there also has to be a lot of things that we practice to make sure that they stay safe. If you're in the submarine, depending on the kind of submarine, they have emergency surfacing procedures. So they might drop weights so they can rise real quickly. Or there might be ways that you can restart the sub, or backup batteries to power the sub. So there's a lot of safety measures in place to make sure that if something goes wrong, hopefully there's a backup device that can help correct that problem. So great question, Miss Williams' class. Contra's asking, are there underwater volcanoes? Yes, there are. Sometimes there's actually really big ones, like Loihi, the newest, not yet island of the Hawaiian chain. So scientists have found that not only are there hydrothermal vents, which are extremely hot gases spewing out of these underwater towers, but there's also volcanoes underwater. So the Hawaiian island chain is caused by a hot spot. So as the tectonic plates move across this magma, there's a hot spot that causes a plume that pushes the magma, which turns into lava above land, out. And that's where you get the Hawaiian Islands from. So as it moves, you get new spots. Now the newest, soon-to-be island, I think has 10,000 years before it peaks the ocean surface. So there's some time to plan your vacation. But yes, there are underwater volcanoes. Now these are hydrothermal vents, which are not exactly a volcano, but they're caused by the same process. Superheating in the Earth's crust and core. So there's gases and there's water in some of these crevices, and as this heat from the Earth itself, it's called geothermal energy, warms this up, causes this stuff to come out, it carries with it a lot of these chemicals and different residues and things, and it helps create these what are often called black smokers, or the hydrothermal vents, and they create these unique ecosystems. So in this ecosystem, I can't even see if there's some crabs or things running around. I think there might be somebody down here. But you get like deep sea clams, deep sea tube worms, and tube worms are actually not like little tube worms. They get like 4 or 5 feet tall. You get a lot of animals on these hydrothermal vents, and because of the pressure that pushes down, it doesn't cause it to steam. So have you ever made tea or boiled a bottle of water or a pan of water to make something? As you heat it up, it hits the boiling point, it turns into steam. It's a phase change from liquid to gas. Well, in the ocean, it's so high pressured, it can't turn into a gas. It stays liquid. So the water around these deep sea vents stays liquid. So it's superheated past the boiling point, 212 Fahrenheit or 100 Celsius. And these animals, if they venture too far away from the vent, the ambient temperature will drop. The sea temperature away from vents this far down might be like 34, 37 Fahrenheit. So like 37 Fahrenheit is about 4 Celsius. 4 Celsius is about as cold as it gets before water starts turning into ice and getting less dense. So 4 Celsius is the densest water will be. It's really cold down there. But they need that heated vent space to be warm. And if they get too far away or too close to the vent, they have their own hazards of, they have this Goldilocks zone they have to stay in. So it's not too hot, not too cold, but it's still pretty hot down there because you're near a vent that's over 100 Celsius. It's pretty amazing stuff down there. Now, Miss Stanford's class is asking, how much air would a person need to bring with them in those mini submarines? That's a calculation I actually don't know, because as you go deeper in the water, even in a submarine, the pressure will enact its own forces into the submarine, and it changes how you absorb oxygen. So if you're scuba diving, the deeper you go, the faster you use up your air tank. So one of my favorite things is when they have like these monster movies where you go diving in the water like this person is, and they go really deep down, say, I don't know, 47 meters. If you're that far down in the water, you have about 10 to 15 minutes of air in a full tank. The movie would be very short. So when you go deep in the ocean, you use up more oxygen. Now, if you're going super duper deep, they actually will change the mixture. They'll change different gas mixtures, or they'll even add helium to it to change a little bit of the mixture so you can survive with your air tank longer and it'll last longer. In a submarine, they have to be concerned about that too. So in those deep sea subs like Alvin, there's a calculation of how much air they would need, how many staff can they put in there, and how long can your dive be for a depth you're going to. So there is like the other question from Miss Williams' class. Are there any ways to stay safe? Yes, make sure somebody knows their calculations for how much air you need in something like Alvin. Now, the window for windows are right there. They're like this big, maybe this big, and it's I think in some of them 9 to 12 inches thick of an acrylic or something that doesn't crack easily. Acrylics don't really crack. So a very thick but very small window to allow them to see out. So if you're not in this big sphere, like in that other submarine we saw, you have to have very special windows that go in. Windows in, ocean exploration and space exploration cause a weak point. So you have to make sure that the window is put together correctly. Otherwise you get leaks, and leaks are bad. Because in the deep sea, because there's so much pressure pushing on things, the crush effect is because it'll squeeze all the air out of your submarine, or even like a soda bottle. You just fill it with air. It hits a certain point where we'll crunch it all the way down. Now, one of my other friends also got to serve on the Nautilus, and they sent down a styrofoam cup. It's actually a pretty common but fun thing to do. So my friend Katie got to go on the Nautilus also, and they send these styrofoam cups down with Hercules, their submarine, or their ROV, and measure the depth that it was at, and it crushes all the air out of the styrofoam. So then instead of being a styrofoam cup about this big, like the size of a normal coffee cup, it's like this big. And it's very thin because it squishes all the air out. So the air pressure or the water pressure on your air is going to be something else that you have to make sure that you are aware of and understand the dangers of, which again is why a lot of things are moving into the ROV realm. So this is Hercules. The ROV realm takes away the human element from being underwater. You don't have to worry about air tanks. You don't have to worry about that happening to people. But you still have electrical things that might happen. You have to make sure all the parts are enclosed in a way that allows it to be safe. Now, we talked a lot about deep sea exploration. We didn't talk about stuff up here in the surface a whole lot. So, like, this is in the depth, and then the Nautilus is up here. But then, is there any other way we can explore our oceans? Do we have to be in the water to explore part of the oceans? No, we don't. We can actually use satellites and buoys. We personally don't even have to be in the water. NOAA has a lot of buoys distributed out throughout the ocean and will give us wave heights, water temperature. Some of them have wind speeds. But satellites can also monitor conditions too. So there's a lot of ways to monitor and explore the oceans without having to be in the water. Or you can have a remote operated vehicle. So this thing we talked about a little bit earlier, you can program it, launch it. It goes off and does its own thing, comes back to the surface, sets up a GPS thing so it tells you where it's at. You go get it, and you download the data. These are really, really cool technology. These are kind of the forefront of being able to explore sometimes interesting depths, but not super deep depths, to allow you to explore your ocean. So there's a lot of ways to explore our oceans. from walking the beach to scuba diving to submarine diving to remote vehicles, automated vehicles, satellites. There's a lot of ways that we can explore our oceans. But what are we really collecting? Are we just going to go? Or what are we doing? So we talked about measuring or like photographing almost the ocean floor. We need to know what the ocean floor looks like. You plan on driving something around down there, you're going to want to know where to go or what you might find. We also don't know as much about the species that live at these depths. So I think NOAA updated its, we've explored this percent ocean to about 90%, which is including depth space. Not just how much of the seafloor have we mapped, because we've mapped quite a bit of the seafloor. But the entire exploration measurement is about 90%. We know more about Mars than parts of our ocean. Now, it used to be we had more people land on the moon than have been to the deepest part of the ocean. I think that number is up to 20 people have visited the Mariana Trench now. That's pretty impressive. 12 people landed on the moon. Only 20 or so people have been into the Mariana Trench. We've sent a lot of people off-world, but we don't really understand the oceans as much. So there's a lot that you can do. If you are interested in being an ocean explorer, do you remember all the different jobs we talked about today? You can be a lab person on the boat, checking the samples, washing the materials. You could be an engineer that builds the machines. You could be the driver that drives the ROV. You could be the ship captain that controls the ship. You could be the person that drives the boat. So the boat crew, the engineering team, the research teams, the public information teams, like what we're doing, we're discussing with the public. There's a lot of people involved in ocean exploration. So you don't have to be the super scientist. You could be the person that builds the best ROV ever. You could be the person that is an amazing electrician. You can get out on research vessels and get out there and help explore. You could be a person that just goes to the beach, uses a mobile device with those animal identifier apps like iNaturalist to record what you find. You can help explore the oceans in so many ways. You don't have to be a marine biologist. You can be so many different things. You could be whatever you want and still explore the oceans. Or you can make it your career. So there's lots of options available to you if you want to help explore our oceans. If you have more questions, because there's a lot of interesting and kind of big ideas in ocean exploration, check out our email, live@lbaop.org, and you can email us more questions. Now, I recommend you go out there and explore your own, looking up information about the Nautilus, the Falcor, the Okeanos, looking up documentaries about ocean exploration, not just deep sea ocean exploration, but maybe the history of ocean exploration. Like Jacques Cousteau was one of my heroes when I was a young person, and that's one of the things that I loved and got into marine science from, was people like that. So find your heroes in ocean exploration, see what they're doing, and you can help them too. Well, thanks for watching today, and we'll tune in next week for more Aquarium Online Academy. Have fun over your weekend, and enjoy.